Hello everyone, my name is Chris Edwards, and today we are going to write a SQL query. Our problem today involves a special kind of join technique that is an indispensable part of your SQL writing toolkit. A local dog grooming salon offers two main services for its furry clientele: bathing and nail trimming. A nail trim appointment lasts only 15 minutes and is relatively cheap, while a full-service bath appointment lasts a full hour and is much more expensive. Currently, the cheaper nail trim service is much more popular than the expensive bathing service, but the salon manager wants to change that. The manager wants to run a special promotion to try to convince current nail-only customers to try out the premium bathing service. The salon's appointment booking system maintains two database tables: bath appointments and nail appointments, with the following structures. To help the salon manager figure out which clients to include in the promotional campaign, we need to write a SQL query that returns a list of dog names that have had at least one previous nail trim appointment but have never booked a bath appointment. The results should contain no duplicate names and should be sorted in alphabetical order by name. And that's all the setup for today. If you want to have a crack at solving this problem yourself, there are links in the video description to this full problem statement and instructions on how to replicate this coding environment on your local machine. Feel free to pause the video now and come back later for a solution walkthrough coming right up. Alright, welcome back everyone. We will now take a look at a few possible solutions to this problem. I'm going to get right to the point with this one, since more than any previous problem I've solved on this channel, this one was designed to showcase a very specific SQL concept, specifically the anti-join. If you think of a regular join as a way to bring together rows with common values found in both tables, an anti-join is basically just the opposite of that, identifying rows in one table that do not match any rows in the other table, based on some specific condition. In our case today, the condition is a very simple one, an equality match on the dog name columns. Does the dog name from the nail trim table exist in the bath table? Now, once you've identified that a problem calls for an anti-join, you have at least three options for how to implement it: using a left join with a null check, using a not in clause, and using a not exists clause. I'm going to briefly review each of these possible solutions now. So I'm going to start with the strategy that I have personally used the most, the left join with null check strategy. As the name implies, this strategy has two components: a left join and a null check. To better explain exactly how this works, I'm going to start with just the left join part and build up from there. So, all this query is doing is left joining from the nail trim table to the bath table. And to better illustrate the point here, I'm selecting the dog name columns from both the left and the right-hand tables in this join. As you would expect from a left join, the results contain all dog names from the left-hand table, nail trim appointments, but only contain matching dog names from the right-hand table, bath appointments. For rows that couldn't find a match, the query just returns null for any values sourced from the right-hand table. And this gives us a very convenient way to identify values that only exist in the left-hand table. We just need to filter out the records that return non-null values from the right-hand table. Put another way, we need to filter to rows where the key column from the right-hand table is null. And if we add in that filter right here and just clean up our output a little bit, you can see we are now returning the expected results. And that, in a nutshell, is the left join with null check strategy for anti-joins. Moving right along to the next strategy, the not in clause. A very natural way to describe our current problem in plain English would be to say something like, find all the dog names from the nail trim table that are not in the bath table. And it turns out there is SQL syntax that lets us write almost exactly that. As you can see here, we are selecting the list of dog names from the bath appointments table in a subquery and passing the results to this not in clause. And it works pretty much the way you would expect. It filters the overall query results to only those dog names that do not appear in the selected dog name column from the bath appointments table. There's honestly not too much more to say about this one, so I'll just move on to the third and final strategy, the not exists clause. This one is kind of similar to the not in clause strategy in that it uses special syntax in the where condition in conjunction with a subquery. But there are some important differences. As you can see, the subquery used in this strategy is kind of unusual in that it actually references a column, the nail trim dog name column here, from the outer query. This situation, a subquery referencing values from the outer query, is referred to as a correlated subquery. This correlated subquery is using a where clause to effectively perform a standard inner join between the nail table and the bath table. And therefore, this subquery will return a value every time a nail trim dog name matches a bath dog name. That's the opposite of what we want. We want the dog names that don't match. So we pass this subquery results to a not exists clause. This means that our overall query will be filtered to only return a value when the subquery does not return a value. In other words, when the results of the subquery do not exist. I'll admit, I find this strategy kind of convoluted, and I personally don't use it that much, if at all, but it is a perfectly valid way to implement an anti-join in SQL, and it's worth mentioning. So, that's a quick overview of the three main strategies for performing an anti-join. Your next question might reasonably be, which one should I use? Is one of them better in certain situations than others, etc.? And the most important takeaway here is that it mostly depends on which database system you are using and how these three strategies are treated under the hood in that specific system. Before deploying one of these strategies in your production code, you should do some research and potentially analyze some query plans to fully understand the implications each of these strategies has for your database's query planner. It's quite possible that the choice makes no difference, that your database translates all three of these strategies into the exact same query plan under the hood. It is also possible that the database treats one or more of them differently, which can have some performance implications depending on which one you pick. So in short, it depends, and you just got to do your research. That being said, beyond pure performance considerations, there are a few other differences between the strategies. Notably, the not in clause strategy is the most restrictive because it only works with equality comparison logic. It is also much harder to use if you need to compare values across multiple columns instead of just one column like in our problem today. In contrast, the left join and not exists strategies can work with any comparison logic across any number of columns since they're just taking advantage of standard join syntax and functionality. In general, my favorite strategy is the left join strategy, since it works in every situation and I find it a little more intuitive than the not exists strategy. The one thing to keep in mind when using the left join strategy is you need to be careful picking the column from the right-hand table on which to perform your null check. You need to pick a column that will only be null if no match was found. If you perform the check against a column that actually has nulls in it already, then your anti-join logic will have a bug in it. you will run the risk of returning rows that do match to rows in the right-hand table if those rows just happen to have nulls in the column you're checking. You can usually avoid this issue by doing the null check against the key column or columns that you are joining on, since those wouldn't return a match anyway if the key column value was null. And with that, I think that's it for this video. Thank you all for watching. If you have any further questions about this problem, or if you think of a different approach to the solution that I may not have considered, please let me know in the comments, and be sure to subscribe for more SQL query writing content in the future. Until next time, happy querying.